Hey everybody, welcome to the channel. We're working on an older car. It's a 2005 Chevy Malibu with a 3.5 liter. Very good engine, very good transmission overall, great car. This one, though, is struggling quite a bit with some interesting symptoms. I've been driving it around for about 2 hours, and finally, we're getting it to act up. This is intermittent, it comes and goes. So follow along, let's get this thing diagnosed. Try to get a picture of the engine shaking. These are always hard to capture. Put my microphone up there, maybe you can hear it. Struggling quite a bit. Now we do have a check engine light. We didn't have a check engine light on prior or previous to this all happening. It just turned on, and we didn't have any codes either when I first started this. No codes, but here we are, check engine light. So let's check those codes. That flashing is just my camera's refresh rate, so it's actually not flashing in real life. So pull up the codes. We have two codes. P0300, that's multiple cylinder misfire. Sometimes you'll hear people refer it as a random misfire, but actually it means that there's at least two or more cylinders misfiring at the same time. So multiple cylinder misfire. And then a 0171, fuel system lean, bank 1. So keep that in mind. So it's only affecting one bank, or at least that's what the engine computer has flagged for bank 1. Bank 2 still may be lean, but it flagged bank 1 as a code. So let's read some live data. Go to engine controls, go to misfire data, and let's see what cylinders it says. Now misfire data you can't always trust. This is a computer's interpretation of which cylinder is misfiring based on the speed of the crankshaft. So as a cylinder fires, it should speed up the crankshaft for a duration of that power stroke. If it does not, if it slows down, then it flags it as a misfire. But it's not always accurate, just something to keep in mind. So let's hit OK. It's running rough at this very moment. And we have cylinders 1, 3, and 5. Looks like a couple on 6, but the majority is 1, 3, and 5. So again, that's all bank 1. So bank 1, cylinders 1, 3, and 5. It started running good. That's another crazy thing about this. It's intermittent. Right now, it's running perfect. The RPMs aren't fluctuating. They're right where they need to be. Oh, now we started cutting out a little. Notice our misfires. 1, 3, 5. Again, 6 has a couple, but it's not. Oh, 2 had 1 there for a second. But the majority of the misfires that the engine computer sees anyway is coming from 1, 3, and 5. So that's one whole bank is cutting out. All right, based on the information that we have so far, it looks like it's affecting one bank. So whatever is causing the issue is dropping cylinders 1, 3, and 5. At least that's what the engine computer thinks. Let's gather a little more information before we start testing stuff. All right, so we want fuel trim data. And we're going to select all the oxygen sensors. There's 4 oxygen sensors on this, 2 upstream, 2 downstream. And then we're going to do the short-term fuel trims, bank 1 and 2. We're going to compare the two with each other. We know bank 1 definitely has a problem, but we want to see if bank 2 has a problem, and maybe the engine computer just doesn't recognize it, or it doesn't throw a code for it, even though there is an issue. So we'll hit OK. We'll throw this on the graph. All right, let's let it roll for a little bit. Collect some data. It's running really rough right now. So this is bank 1 upstream, bank 1 downstream, bank 2 upstream, bank 2 downstream, fuel trim bank 1, fuel trim bank 2. So remember, all the bank 1s will follow that code. So these 2 right here are bank 1, and then this first one here for the fuel trim is bank 1. So let's just let it run for a little bit. It's running okay right now. Starting to run rough again. See our fuel trims climbing. They're maxed out there at 26. All our O2 sensors have dropped. Oh, there we go. We're running good again. Our fuel trims are dropping. Our O2 sensors are up. It looks like our upstreams going flat again. And our downstreams, if it follows the pattern, will start to drop. There we go, we're dropped. We're pegged out on our fuel trims. Take a picture of that. So our O2 sensor data and our fuel trim data paints a little different picture than our misfire data. If we went on misfire data alone, we would be looking at one bank. But as we see here, this is actually affecting both banks at the same time. Now with that information, what are you thinking? Some of you might be thinking, well, mass airflow sensor or MAP sensor. Okay, that is a valid thing to check because the engine computer needs to know how much air is entering into the system to know how much fuel to mix with it so you get that stoichiometric or that perfect balance between fuel and air. Well, how does the engine know how much air is in the system? The mass airflow sensor or the MAP sensor, depending on your vehicle, you may have one, you may have the other, you may have both. On this particular vehicle, there are both, but the MAP sensor mainly is used for the baro so that it knows your altitude, and it relies more on the mass airflow sensor for the air intake calculations. So let's take a look at both of those sensors and see what's happening. One thing to keep in mind, so what are we looking for? If this is running lean, what numbers on the mass airflow sensor are we looking for? High numbers or low numbers? Let's give that a thought for a second. So think about air-fuel ratio. If the mass airflow sensor is sensing a lot of air, so a high number on the mass airflow grams per second, that means there's a lot of air coming into the engine, then it would compensate by adding more fuel. So if the mass airflow sensor is saying that there's more air coming into the engine than there really is, then we'll see a rich condition because it'll be adding fuel thinking that there's a lot of air when there's not a lot of air. So it'll be adding too much fuel. So what we're looking for is a low number on the grams per second. That would trick the engine computer to think there's only a little bit of air coming into the engine, so then we only need a little bit of fuel to make the proper mixture, when in reality there's more air than the engine computer thinks, so it's not adding enough fuel. So let's take that in consideration. Let's look at our grams per second. We'll also look at our baro, our intake air temp, that's important as well, so that the engine computer can calculate how dense the air is based on its temperature. And then we'll pull up the short-term fuel trims again so you can see what the fuel trims are doing, and we'll compare that to what the grams per second is doing on the mass airflow. All right, so we have the baro selected, the intake air temp sensor, mass airflow sensor, and short-term fuel trim. So it's on metrics. Let's go to English. So we're at 14.7 PSI on the baro, which is perfect. We're about 1,100 above sea level. So 14.7, not too bad. Intake air temp 150, that's right. The engine's been running for a while, and it's about 105 degrees out currently today. So mass airflow, let's switch back to metric because we want grams per second. Now this is a 3.5 liter. These numbers are a little high based on the rule of thumb. Grams per second equals engine displacement. So we would think we want to be closer to about 3.5, 4, but we're a little higher. It's running pretty rough right now. You can see our short-term fuel trims are back up pegged to 26. So it's dumping or trying to leave those injectors open as long as possible so as much fuel as possible can enter into the engine. Now we're dropping back down. Fuel injectors are opening closer to what factory wants them. Now we're climbing back up. Got our mass airflow. Didn't really change. Now it's running rough. We'll see a change in the mass. Now some of this fluctuation can be due to the fact that our RPMs are fluctuating. So as our RPMs fluctuate, the amount of air entering into the engine is going to fluctuate. But we're pegged out. Remember, we want these numbers to be low in order for our lean condition, but they're not. They're a little high, so that's not going to be the cause of our lean condition. And you notice it didn't really move much between when it started to act up and when it's acting right. With that information on the mass airflow sensor, a valid test to see what it's doing, I don't believe our issue is air related. So I don't think it has to do with a sensor tricking the engine computer into thinking it's one way when it's not. I don't think that's our issue. I think this whole thing is on our fuel side. So I don't think it's the air side of things. I think it's the fuel side of things. So let's hook up a fuel pressure gauge. We'll also hook up to cylinder number 1 fuel injector to make sure that it's still operating when this cuts out, and also cylinder number 1 ignition coil, just to make sure that this isn't ignition related as well. So we'll hook up our scope to those things, we'll get some data and go from there. All right, just so you can see, I'm back probed right there to fuel injector number 1, to the power and the ground. It's a ground size switch, so we should have power at all times, and then the ground will switch from power to ground, and then you'll get a spike. We'll show you that on the scope. Oh, almost died that time. And then our ignition is on cylinder number 5, and we'll see that on the scope as well. So currently we are idling fine, no misfires. We'll start our scope. The red is our injectors, the yellow is our power to the injector, and the green is our ignition. Oh, there we go. You see we're starting to misfire a whole bunch. And if you look, everything looks pretty good. Let me stop, because all we needed to do was record until we started misfiring. And if you look, we didn't have any dropouts anywhere. So I would imagine if we had that many misfires, that there'd be big sections gone and missing. Let me show you on the scan tool what I'm talking about. Well, let's get rid of the red first real quick. So that's our power, and if you look, we're right about 13.5 volts on our power, and it stayed nice and smooth. Our ignition is kind of choppy and hard to understand. Let's zoom in on a chunk of it. But we have all our ignition strikes. We didn't lose any ignition. Now this is waste spark system, so you'll get a high and a low, high and a low. It'll kind of fluctuate like that, no big deal. That's normal. So this looks normal. Let's zoom back out. Let's turn that off and that off. Zoom out, and that looks really good all through here. So no dropouts. Let me show you what I mean by a dropout. So on our scan tool, we're gonna purposely disengage. We're gonna actuation test, fuel system, power balance. We're gonna shut off an injector. Hit okay. So now we're gonna do injector number 1, because that's what our scope is hooked up to. I'm going to disable. Before I do that, let me show you. I'm gonna start recording. Let it populate a little bit. Okay, so nice even lines, perfect in time. So let me hit the disable button. Well, it's running rough. Let me not kill it. Let me wait a second. All right, it just pulled out of it. So it just pulled out of it. Now I'm gonna turn off the injector. I'm gonna hit this disable button and watch what happens to our scope. And then I just enabled it. So you see that big empty space? Go ahead and pause. So that's a dropout. So that means that the engine computer was not controlling the injector. All right, perfect. So with that little test, we found out that it's not an ignition issue. So our ignition module, or the computer controlling the module, isn't failing. We got complete control of our ignition the whole time, and it's not a fuel injector issue. So it's not a failing engine computer controlling the injectors. It's not a failing power signal or a failing ground or anything like that. We have complete control of our injectors the entire time. So now let's hook up our fuel pressure gauge and see what's happening there. All right, Chevy makes it nice with the Schrader valve right there hooked up to our gauge. That's key on, engine off, and we're right about 45 pounds of pressure. So not too bad, key on, engine off. That's a nice pump pressure. Oh, let's start it up. Check the pressure when it starts acting up. All right, we're running, idling fine, just over 50. I don't know the specs on what this is supposed to be, but that's plenty of pressure. Needle's starting to jump around. Uh-oh, losing pressure. And there we go. Engine running really rough. Barely have over 10 PSI. And then boom, kicks back on, we get full pressure. Oh, we just lost it again. Let's look at some scan tool data so we can see what the engine computer is showing. So we have very little pressure at the moment. We'll go over here and graph. So the top is our upstream O2 sensor on bank 1, and we have fuel trims on bank 1. And we're pegged at 26. And that's because the injectors are open as far as they can open to allow as much fuel as possible. And it's probably not very much fuel at all with those pressures. Now we just gained pressure again, and look, our O2 sensors went rich and our fuel trims are dropping because now we have more pressure, so the injectors don't have to be as open as long. Pressure's dropping back down, fuel trims are climbing, and our O2 sensor's reading lean. Let it do its thing for a while. There we go, back up. And you can see how our fuel pressure, the change in our fuel pressure affects our O2 sensor and our fuel trims. Now we're back down. This will start to climb. That drop back down. All right, we found the culprit. We're losing fuel pressure, which makes sense with our scan tool data. With the O2 sensors going lean, our fuel trims going up, it's not getting enough fuel. Now, is this a wonky fuel pump? The pump itself that's starting to fail, shutting off, coming back on, shutting off, coming back on? Or is the pump losing power, or is it losing ground? Do we have another issue that's causing this? The fuel pump is run off a relay, and the relay is controlled by the engine computer. So if we're missing a power to the pump when this starts happening, then we need to track the circuit back towards the engine computer. Or if it's a ground that we're missing, then we need to find where the ground is, trace that wire, and find the issue there. Or it could be a faulty fuel pump. Well, how are we gonna tell? Again, we're gonna use our scope. So we were in the back of the car by the fuel tank, and we back probed into the power and ground going to our fuel pump. All right, no misfires, we're running pretty smooth. Let's go ahead and start this. So our top is our power at about 13 volts, and our bottom is a ground right around 0. So we're just gonna wait for it to start cutting out and see if anything happens to our power or our ground. Okay, there we go. Cutting out, lots of misfires, running really rough. And our power and ground did not move. All right, there we go. We saw it cutting out, but our fuel pump still had good power, still had good ground. That's all it needs in order to pump is a power and a ground. It's a simple motor. The fact that we kept our power, we kept our ground, tells me that this fuel pump is no good. There's some kind of internal glitch, internal failure inside the pump. Maybe it's overheating, kicking off, and then as it cools down, it kicks back on. I don't really know. Either way, this fuel pump module needs to be replaced. This last test we did with the power and ground at the pump, that can be done with a multimeter. Doesn't have to be done with the scope. That can be done with a multimeter. The scope is just easy. We plug it in, we sit in the front seat with the AC on with our laptop, so it just makes it easier, but it could be done with a multimeter. The injector ground cannot be done with a multimeter. You will need a scope to see that ground fluctuate. You want to see that good pattern or that good waveform on that scope control side, but you can multimeter the power side of it, because if we're getting a dropout on the power side, you'll see that on a multimeter happen as well. So a multimeter on the power side, but not the ground side. What else? The ignition can be done with an inline ignition tester, a little light bulb. I've seen those before where it just lights up the bulb, but it's inline, so it still can fire the the spark plug in the cylinder, but you see that inline flash as it's sparking. So then you can see if it stops sparking, then you know, hey, we just lost ignition. So that could be done with a different tool other than an oscilloscope as well. You could use a spark tester. Other than that, really the biggest tool here that helped was having a fuel pressure gauge. So scope makes things easy. Some things are scope only. I like using it because of the convenience, but the fuel pressure gauge would have, with the nice scan tool pointing us in the fuel pressure arena, then having that gauge would have been the ticket. All right, well, thanks for watching. Like, subscribe. See you on the next one.